It is the one dimension we cannot escape, the invisible thread tying every heartbeat, every sunrise, every memory into the story of existence. We feel it passing in the ticking of a clock, in the wrinkles on a face, in the decay of a fallen leaf. Yet, for all our dependence on it, time remains the greatest enigma of the universe. We live inside it, move through it, and measure our lives by its rhythm. And yet, what if there are places in the cosmos where time does not simply bend or slow, but stops? What if the current that drags us all forward into tomorrow can, in certain corners of reality, freeze into silence? The thought alone unsettles us. Time is our most constant companion. Strip it away, and the universe itself seems to crumble into incomprehensibility. Imagine standing at the threshold of such a place, your body, your mind, your entire existence trapped in a single instant, while the stars above you continue their endless march across the heavens. To you, no seconds pass, no change occurs. To the rest of the cosmos, millions of years unfold while you remain locked in eternal stillness. From the moment humans first gazed at the night sky, questions about time have haunted our imagination. Ancient civilizations built sundials and calendars not merely to track the seasons, but to make sense of a force they could never fully grasp. For the ancients, time was tied to the divine, an order imposed upon chaos, a rhythm set by gods. For us, time became a scientific puzzle, dissected into hours, seconds, nanoseconds, even quarks of possibility. But none of these measurements bring us closer to answering the unsettling question: is time an unbreakable law of nature, or is it a fragile illusion that collapses under the right conditions? The modern world assumes time flows like a river. We trust its current without question. We wake, we work, we sleep, always moving forward. Birth gives way to death, moments vanish into memory, and tomorrow always arrives. But rivers can freeze. Rivers can vanish underground. Rivers can become lakes where no current flows at all. So too, perhaps, with time. The possibility is not science fiction. It is science fact. Across the cosmos, there are domains where the rules we consider universal falter. At the edges of massive black holes, on the highways of light-speed travel, within the bizarre whispers of quantum particles, time behaves in ways that defy all ordinary understanding. And it is here, where the familiar dissolves, that the human mind is forced to confront a reality stranger and more unsettling than any dream. Think for a moment about what it means to live in a world without time. Without seconds, there is no motion. Without motion, there is no change. Without change, there is no life, no history, no story. Every laugh, every tear, every triumph, every failure, erased into a single unending instant. Eternity sounds like a promise when whispered by poets and priests. But in its truest form, it is a prison. And yet, paradoxically, there is also beauty in the idea. If time can stop, perhaps moments can be preserved forever. Perhaps the kiss of a lover, the cry of a newborn child, or the sight of a sunset spilling fire across the horizon can be trapped outside of decay. Eternity is both horror and hope, destruction and salvation. It is the knife edge on which the entire film will balance. The story you are about to witness is not a fantasy. It is a voyage into the heart of physics, philosophy, and imagination. We will travel to the darkest abysses of space, where time freezes at the edge of forever. We will step into the impossible speeds where a second stretches into centuries. We will sink into the quantum fog, where cause and effect no longer march in order, but flicker like ghosts. Each destination is stranger, darker, and more wondrous than the last. But this journey is not only about the universe, it is about us. Why are we so afraid of timelessness? Why do we cling to the ticking of clocks, to the passing of days, to the illusion that the future is guaranteed. The truth is simple. Without time, we lose identity. We lose story. We lose meaning. To imagine a place without it is to imagine ourselves unmade. And yet, within that terror lies a question we cannot ignore. If time can stop, does that mean we can escape it? Our adventure begins with a paradox. We are bound by a chain that may not exist. We are trapped in a current that may not flow. The universe whispers that the clock is not universal, that, in certain corners of its vast expanse, the ticking halts altogether. What awaits beyond those frozen frontiers? What becomes of matter, of light, of consciousness itself, when the river of time turns to stone? As we descend deeper into this mystery, we will confront black holes that devour time itself, neutron stars where seconds collapse, wormholes that might shatter chronology, and even quantum states of matter where time dances in loops. We will wrestle with philosophers who argue that time is an illusion we project upon reality, and scientists who warn that the end of time is not just possible, it is inevitable. At every step, contrast will guide us. The hope of eternal preservation against the horror of eternal stillness. The dream of transcending time against the dread of being consumed by it. For time is not merely a scientific dimension, it is the fabric of our deepest fears and highest aspirations. This is more than a documentary. It is a mirror held up to the universe and to ourselves. By the end, you may find your faith in time shaken, your understanding of reality fractured, and your imagination set ablaze with possibilities. So let us begin, not with the ticking of a clock, but with the silence of a void. A silence where the seconds refuse to march, where the future never arrives, where the past never fades. Welcome to the places in space where time stops existing. Time to us is not abstract, it is personal. We do not simply measure it, we feel it. A racing heartbeat before a fall, the long drag of hours in loneliness, the fleeting instant of joy that vanishes too quickly. Time shapes the contours of our inner lives just as surely as it carves mountains and erodes stone. To understand why the absence of time is so unsettling, we must first look at the ways in which we, as humans, have built our existence upon its steady rhythm. For millennia, we have relied on nature's clocks, the sun rising over the horizon, casting long shadows that shrink and stretch through the day, the waxing and waning of the moon, marking the passage of months, the changing seasons, reminding us of cycles older than civilization itself. Our ancestors built monuments aligned with solstices, carved calendars into stone, and measured shadows to predict harvests. Time was not just practicality, it was sacred, a language through which the universe spoke. As societies advanced, our tools for capturing time became sharper, more precise, almost obsessive. The sundial gave way to water clocks, dripping one measured drop after another. Sand flowed through hourglasses like golden rivers, each grain a moment lost forever. Then came the mechanical clock, with its gears and pendulums ticking like the heartbeat of civilization itself. The invention of accurate timekeeping was more than a scientific triumph. It was a revolution in human consciousness. For the first time, minutes and seconds had weight. Human life could be sliced into fragments, regulated, synchronized across entire cities. But time is not only external. It pulses inside us. Our bodies are living clocks, tuned to rhythms we often ignore. The steady drumbeat of the heart, the rise and fall of breath, the cycles of sleep and wakefulness, guided by circadian rhythms etched deep into our biology. Even at the cellular level, tiny molecular clocks keep track of processes that sustain life. Every beat, every breath, every blink is a reminder that our existence is inseparable from time's flow. And yet, paradoxically, our perception of time is fragile, elastic, easily deceived. A child's summer seems endless, stretching with infinite possibility. To an adult, those same months vanish in a blink. A moment of terror can slow into an eternity of hyper-awareness, while hours spent in joy collapse into what feels like seconds. This elasticity reveals that our sense of time is not absolute but subjective, bound to emotion and memory. Time in our minds does not always march. It dances, stumbles, and sometimes skips entirely. This fragility exposes something deeper. Without time, we lose coherence. Imagine memory without sequence. Without a before and an after, experiences cannot form a story. They become fragments without meaning, scattered images without a thread. Identity itself, our sense of who we are, depends on time's arrow. We are not simply beings in space. We are beings stretched across past, present, and future. Remove the timeline, and the self dissolves into confusion. This dependency explains why the idea of timelessness unnerves us. It is not merely about physics or astronomy. It cuts to the core of human existence. If time can stop, what happens to memory, to thought, to the very narrative of our lives? Without the steady tick of the internal and external clock, are we even human? Yet, for all our dependence, we have always pushed against time's constraints. We invent rituals to preserve moments. Paintings, songs, photographs, films, all attempts to cheat time by freezing an instant. We celebrate birthdays and anniversaries as markers, proof that the past is real and connected to the present. In every tradition, in every culture, humans have fought against the flow, desperate to hold onto the ephemeral. Our obsession with time also shapes our ambitions. We race against it in medicine, striving to extend life, to delay the inevitable. We design technology to accelerate our work, to make more of the hours we have. We dream of time travel, of bending it to our will, of escaping its limits entirely. Beneath every pursuit lies the same unspoken fear, that time is not just a measure but a thief that steals youth, steals moments, steals everything. But the cosmos does not share our obsession. Time, as we know it, may not even exist outside of our perception. Physics tells us it bends, stretches, halts under extreme conditions. What we experience as rigid and universal may be nothing more than a local illusion, a convenient rhythm that collapses the moment we step beyond Earth's protective cocoon. Our human clock is fragile, provincial, blind to the enormity of the universe. And that is where the true terror begins. If our entire identity, our society, our perception of reality is built upon time, and if time itself is not fundamental but conditional, then everything we take for granted is resting on shifting sand. The calendar, the heartbeat, the tick of the second hand, they are fragile structures clinging to an indifferent cosmos. To grasp the places where time stops, we must first accept this uncomfortable truth. The clock we live by is not the universe's clock. It is our invention, our comfort, our prison. We measure the immeasurable, divide the infinite into seconds and minutes, hoping the illusion will hold. But the deeper we venture into space, the more the illusion shatters. Our journey begins here, with the fragile human clock. Because once we leave it behind, the true nature of time, strange, elastic, terrifying, emerges in full. And the further we go, the more we must ask, if time can fracture, what becomes of us when the clock stops ticking? At the dawn of the 20th century, physics stood at a crossroads. For centuries, Isaac Newton's laws had ruled the scientific imagination. The universe, as Newton described it, was a grand clockwork, predictable, mechanical, governed by absolute space and absolute time. According to this vision, time ticked at the same rate everywhere, for everyone, an invisible metronome keeping order across the cosmos. The universe seemed rational, comforting, and eternal. But then, a young patent clerk in Switzerland, armed not with a laboratory but with thought experiments, shattered that certainty. Albert Einstein's theory of relativity was not just a scientific breakthrough, it was a philosophical earthquake. Time, the most stable of Newton's absolutes, was no longer fixed. It was fluid, elastic, woven together with space into a single entity, spacetime. What we once believed to be universal and unchanging turned out to be relative, shifting depending on speed and gravity. This was Einstein's bombshell. Time itself could bend. To grasp the magnitude of this revelation, imagine a train racing along tracks at near the speed of light. On board, a passenger strikes a match. To them, the flame bursts instantly into existence, burning as naturally as it would in any room. But to an observer standing outside, the events unfold differently. Because the train is moving so fast, the light from the match seems delayed, stretched, distorted. The passenger's time and the observer's time no longer agree. Two realities, equally valid, exist side by side. Time, it turns out, is not universal. It depends on where you are and how you move. This relativity of time is not mere theory. It has been tested again and again with astonishing precision. Consider the Haffel-Keating experiment of 1971, in which atomic clocks were flown around the world on commercial airplanes. When compared to clocks left on the ground, the airborne clocks disagreed, not by seconds, but by billionths of a second, exactly as Einstein predicted. These tiny discrepancies may seem trivial, but they prove an extraordinary truth. Time ticks differently for each of us, depending on our speed and our position in gravity's grip. The implications ripple outward. A satellite orbiting Earth experiences time differently than a person standing on the ground. This is not hypothetical. It is the reason GPS navigation works. Without corrections for relativity, your phone would misplace your location by kilometers within minutes. Every map, every journey, every digital path traced across the Earth relies on Einstein's discovery. His theory, born from imagination, now guides billions of lives daily. But relativity does more than bend time. It alters our entire perception of reality. Imagine two twins, identical in every way. One remains on Earth. The other boards a spacecraft and travels close to the speed of light before returning home. To the twin who stayed, decades may have passed. To the traveler, only years. When they reunite, one is aged, the other still young. This is not fantasy. It is the twin paradox, a logical consequence of relativity and a haunting reminder that time is not equal for all. At its heart, Einstein's revelation was simple yet profound. Time and space are not separate backdrops for the universe's drama. They are the stage itself, capable of stretching, twisting, and warping under the influence of energy and matter. Massive objects, like planets and stars, do not merely sit in space. They bend it, curving the very fabric around them. And with space curved, time itself bends along. This is why clocks run slower in stronger gravity, why the tick of a watch on Earth's surface differs slightly from one high above the atmosphere. Gravity is not a force pulling objects together, as Newton imagined. It is the shape of spacetime itself, guiding matter along its curves. The beauty of Einstein's insight is how it merges the poetic with the terrifying. Imagine light bending around a star, time stretching at the edge of a massive planet, the universe itself sculpted by invisible geometry. It is cosmic artistry painted not with colors, but with equations. Yet it is also a glimpse into something darker. If time can bend, can it break? If it can stretch, can it snap? Einstein himself wrestled with these questions. His equations predicted black holes, regions so dense that time slows to a crawl, where spacetime itself folds into a singularity. At first, even he resisted the idea, doubting nature would allow such monstrosities. But the mathematics was clear, and later observations confirmed it. The universe is littered with places where Einstein's bombshell takes on its most terrifying form. To understand the shock of this revelation, we must remember what it replaced. For centuries, humans trusted in absolutes. Space was infinite, time was uniform, and the laws of motion were eternal. Relativity swept these certainties away. Time could flow differently for you and me. Space could bend. Even the speed of light, the one constant, meant that the universe itself has horizons, edges we cannot see beyond. Einstein revealed a cosmos far stranger and more unsettling than anyone imagined. And yet, there is wonder too. Relativity does not merely destroy our illusions. It grants us glimpses of the extraordinary. Time travel, once the domain of myth, is embedded in its equations. Move fast enough, and you leap into the future. Hover near a black hole, and while hours pass for you, centuries sweep across the stars. Relativity shows us that the boundaries of human experience are not fixed. They are expandable, elastic, filled with possibilities both terrifying and magnificent. Cinematically, Einstein's discovery is best understood as a tearing away of a curtain. Behind the ordinary flow of seconds lies a universe that is anything but ordinary. Time is not the steady tick of a clock. It is a living, breathing dimension, responsive to speed and gravity. The ground beneath us is less solid than it seems. The seconds slipping through our fingers are not the same for everyone. And the further we venture from Earth, the stranger those seconds will become. Einstein's bombshell was not only a scientific triumph, it was a philosophical challenge. If time is relative, then what becomes of destiny? If the future can arrive faster for one person than another, does the concept of a shared now even exist? Perhaps the present itself is an illusion, a fragile agreement between observers. The universe, it seems, cares little for our human intuitions. This is where our journey must now turn. Einstein opened the door, but beyond it lie regions he himself could scarcely imagine, places where relativity stretches to its limits, where time does not merely bend, but threatens to stop entirely. At the edges of black holes, at the heart of neutron stars, in the whispers of quantum reality, Einstein's equations take us to the brink of timelessness. His bombshell was not the end of the story, it was the beginning of a far deeper mystery. And so, as we step further into the cosmos, we carry his revelation with us. Time is not what we thought it was. It can stretch. It can twist. It can shatter our most cherished certainties. The black hole is the universe's most terrifying paradox, a cosmic abyss where our understanding of reality falters. It is not merely an object. It is an event, a boundary, a place where the laws of physics collide and fracture. At its heart lies a singularity, a point of infinite density where space and time are curved beyond comprehension. But the singularity is hidden, wrapped in a shroud of mystery. The event horizon. This invisible surface is the line of no return, the place where time itself stops. To stand at the event horizon is to confront eternity. From the outside, the horizon appears as a perfect sphere of darkness, silent and absolute. No light can escape, no signal can return. Cross this boundary, and the universe will never hear from you again. Yet the event horizon is more than a barrier to communication, it is a boundary in time. For an observer watching from a safe distance, anything approaching the horizon seems to slow down. The falling astronaut, the drifting spacecraft, the very photons of light, each appears to crawl, then freeze, suspended on the brink forever. Time, from the outside perspective, halts at the horizon. But for the one who falls, reality is different. Inside their perspective, seconds continue to tick normally. Their heart beats, their thoughts race, their body moves. They cross the horizon without noticing anything unusual. The outside world may believe they are frozen in a single moment, Yet to them, time remains intact, until gravity tears them apart. Two realities unfold, equally valid yet impossible to reconcile. The event horizon fractures time into contradictory stories. This paradox creates one of the most haunting images in all of science. A person falling into a black hole, seen from the outside as a frozen silhouette, never quite reaching the edge. To the universe, they are locked forever in a single instant. To themselves, they plunge into the unknown. Which story is true? Both and neither. Reality itself seems to splinter at the horizon. The cinematic imagery of the event horizon is staggering. Imagine a star drifting too close, its outer layers torn apart by tidal forces, spiraling in luminous arcs before vanishing into the abyss. To distant observers, the star stretches and slows as it nears the horizon, its light redshifting, dimming, fading into darkness. But in truth, the star has long since crossed the boundary, consumed in silence. What we witness is an echo, a ghost of its final moments, stretched infinitely by time's distortion. The black hole becomes a mausoleum, preserving the dying moments of everything that falls into it, suspended on its edge forever. And yet, the event horizon is not only a place of destruction, it is also a place of revelation. For decades, scientists debated what happens at this edge. Does information vanish? Does the universe lose pieces of itself forever to the abyss? Or is every detail somehow preserved, encoded on the horizon itself like a cosmic ledger? This is the information paradox, a problem that haunts modern physics. If black holes truly erase information, then the fundamental laws of quantum mechanics collapse. But if information survives, hidden on the surface, then the horizon may be more than a boundary. It may be the ultimate archive of the cosmos. Stephen Hawking once proposed that black holes radiate, slowly evaporating over unimaginable timescales. This Hawking radiation suggests that the horizon is not silent, after all. It glows faintly, whispering secrets back into the universe. If true, then the horizon is not simply a prison, but a doorway between reality and nothingness, between existence and oblivion. The idea that the surface of a black hole holds the record of everything that has fallen into it is both astonishing and unsettling. It suggests the event horizon is not the end, but a mirror reflecting a distorted record of the universe's history. Philosophically, the horizon forces us to question what it means to exist in time. If the outside world sees a person frozen forever, does that image have as much reality as the person's own experience of falling? Are we defined by what others perceive, or by what we ourselves feel? The event horizon is not only a scientific mystery, it is a philosophical abyss, forcing us to confront questions about identity, perception, and truth. The human imagination has long been drawn to boundaries, the edges of maps, the limits of oceans, the horizons where the sun vanishes. The event horizon is the ultimate expression of this fascination, a frontier where reality itself dissolves. To stand at its edge, even in thought, is to face the possibility that time is not what we believe it to be, that it can stop for one perspective while flowing for another, that eternity can exist side by side with a fleeting moment. This duality of hope and horror defines the event horizon. On one hand, it is terrifying, a place of annihilation where time stops and matter collapses beyond recovery. On the other hand, it offers a kind of immortality. From the perspective of the outside universe, anything falling toward a black hole never truly disappears. It lingers forever, frozen on the edge. In this strange sense, black holes grant eternal life, not as consciousness, but as image, as memory, as a ghost imprinted on the surface of spacetime. The tension between these two interpretations, death and preservation, annihilation and eternity, keeps scientists and philosophers alike entranced. Are black holes the end of time, or are they timeless archives of all that has ever fallen? Do they erase, or do they preserve? Do they destroy, or do they transform? Each possibility reshapes our understanding not only of physics, but of existence itself. The emotional weight of this question cannot be overstated. Imagine knowing that from one perspective, you are preserved forever, your final moments stretched across eternity. From another, you are gone, swallowed into silence. The event horizon becomes a cosmic riddle about life and death, about memory and oblivion. It is both graveyard and museum, executioner and archivist. As we leave the event horizon in our journey, we are left with a haunting truth. Time itself fractures at this edge. For some it stops. For others, it flows. For the universe, it preserves ghosts forever. For the fallen, it ends in silence. The horizon is the edge of forever, a place where time ceases to have a single meaning. And yet, beyond this edge lies an even deeper mystery. What happens after crossing? What lies inside, past the frozen boundary? Does time continue to exist at all, or does it vanish completely? The horizon is only the surface of the abyss. Beyond it lies the singularity, the ultimate unknown. And it is there, in that realm of infinite density, that our journey now turns. Gravity. It is the quiet sculptor of the cosmos, unseen but omnipresent. It holds the planets in orbit, binds galaxies into spirals, and pulls the oceans to rise and fall in eternal rhythm. We live under its grip without questioning it, feeling its tug every time we stumble, every time we leap and fall back to the ground. Yet, gravity is far more than a force. It is the architect of time itself. And in the most extreme corners of the universe, it becomes a trap, slowing time until it seems to grind to a halt. To understand why, we must return to Einstein's revelation. Gravity is not a force in the Newtonian sense, but the warping of spacetime. Massive objects bend the fabric of reality, and everything within that curvature follows its shape. But the distortion does not end with space. It bends time as well. Where gravity is stronger, clocks tick slower. The closer you are to mass, the deeper you sink into time's gravity well. Imagine two clocks, one on Earth's surface, the other aboard a satellite orbiting high above. The clock in space ticks slightly faster than the one below, because Earth's gravity grips the lower clock more tightly. This effect is minuscule, measured in billionths of a second, but real and measurable. Without correcting for it, the GPS in your phone would be useless. Every map, every direction, every journey depends on accounting for gravity's influence on time. Now, expand this effect into the extremes of the cosmos. Imagine standing near the surface of a neutron star, the collapsed core of a massive sun. Here, gravity is so intense that a teaspoon of matter weighs billions of tons. Clocks on the star's surface run dramatically slower than those far away. An hour spent there might equal days, months, or years beyond. Time itself bends to the star's crushing gravity, trapping those who dwell within its field. But neutron stars are only a glimpse. The true gravity traps are black holes, regions of space where mass is packed so densely that not even light can escape. Near these cosmic abysses, time becomes unrecognizable. For someone falling toward a black hole, seconds tick normally. But to a distant observer watching from safety, the fall slows, stretches, and ultimately freezes. The traveler appears suspended forever on the edge, trapped in a single moment, as if time itself has stopped. This paradox is the essence of the gravity trap. Two realities unfolding simultaneously, each valid yet impossibly different. To the falling traveler, time continues until the very end. To the outside universe, their story halts at the horizon, an eternal statue frozen in place. Which is true? Well, Relativity allows no single universal clock. Time is not shared, it is fractured by gravity's grip. The emotional weight of this idea is staggering. Picture an astronaut venturing too close to the event horizon. To them, minutes pass as they descend. To their friends watching from afar, millennia unfold. Civilizations rise and fall, stars are born and die, galaxies drift and collide, all while the astronaut is still hanging in that final moment. From one perspective, a journey lasts hours. From another, eternity. Gravity has trapped time in its invisible fist. The cinematic power of this vision cannot be overstated. Imagine standing on a world orbiting a black hole, as portrayed in works of science fiction. On the planet's surface, hours pass. Beyond, in the wider universe, decades vanish. A single step under the shadow of such a monster could cost you your family, your civilization, your entire future. This is not fantasy, it is physics. The universe contains real places where time is so distorted that living there would mean abandoning everything you once knew. And yet, the gravity trap is not merely destructive, it is also revealing. It forces us to confront the fragility of our perception. We assume time is universal, that a second for you is a second for me. But gravity reveals the illusion. In truth, every moment is relative, every clock unique, every heartbeat measured differently depending on its place in spacetime. We live not in a single river of time, but in countless streams, all flowing at different speeds, converging and diverging across the cosmos. Even here on Earth, the gravity trap whispers to us. The time passing for your feet is not identical to the time passing for your head, because gravity is infinitesimally stronger closer to the ground. The difference is imperceptible but real. We are all living in subtly different times, our bodies stretched across gradients of spacetime without realizing it. The everyday world hides the cosmic truth, but it is there, embedded in our existence. The philosophical consequences are profound. If time is so malleable, so dependent on gravity, then what does the present truly mean? There is no single now shared across the universe. There are only local nows, tied to places and perspectives. The universe is not a synchronized clock. It is a mosaic of countless ticking rhythms, each shaped by the invisible hand of gravity. This realization brings both awe and dread. Awe because it reveals a universe stranger and more beautiful than we ever imagined. Dread because it strips away our illusions of unity, of common time. We are each, in a sense, trapped in our own temporal frame, connected, but never identical. The gravity trap is not the end of the story, it is the gateway to deeper mysteries. For if gravity can slow time, if it can trap moments on the edge of eternity, then what happens when we push further? What lies beyond the horizon, where time seems to stop? Does it end altogether, or does it continue in ways we cannot imagine? These are the questions that drive us deeper into the abyss. Gravity has shown us that time is fragile, elastic, and deceiving. But beyond the gravity trap lies an even greater mystery, the edge of forever, the event horizon itself, where time does not merely slow, but appears to vanish. And it is there, in the silence beyond, that our journey now turns. Falling into a black hole is not a smooth descent, it is a death written in slow motion, a transformation so violent and strange that no human experience compares. This fate has a name that sounds almost absurd, yet carries the weight of cosmic horror, spaghettification. It is the inevitable stretching and tearing of anything that dares approach the singularity. Imagine drifting closer to a black hole's core. The pull of gravity is not uniform. It is far stronger at your feet than at your head. At first, the difference is negligible, barely noticeable. But as the distance shrinks, the tidal forces grow. The gravitational gradient becomes a tearing force, stretching your body atom by atom. Your legs are pulled downward, your chest is stretched thin, your arms are tugged apart. Soon, the difference becomes catastrophic. The very molecules that hold you together are wrenched by gravity. You are drawn into a filament, a thin strand of matter unraveling toward the singularity. The silence of this process is perhaps the most chilling. There is no sound, no scream that can escape, no warning that travels back into the universe. From the outside, your image lingers on the event horizon, frozen in time. But within your own perspective, you are being elongated into nothingness. The violence is absolute, yet the universe records it only as a whisper, a frozen silhouette stretched into eternity. Spaghettification is not only a physical phenomenon, it is a philosophical metaphor. It embodies the way the universe shreds continuity, turning wholeness into fragments. It is the transformation of something familiar into something alien. A human being with identity and history is stretched beyond recognition, reduced to a line of matter. The very concept of self is torn apart, dispersed into an unrecognizable geometry. It is annihilation disguised as transformation. But the process is not uniform for all black holes. A small stellar mass black hole, just a few times larger than our Sun, creates tidal forces so extreme that spaghettification occurs well before reaching the event horizon. In such cases, you would be ripped apart long before you even touched the edge. But in a supermassive black hole, millions of times the mass of the Sun, the event horizon lies far enough from the singularity that you might cross the boundary intact. For a fleeting moment, you could drift into the abyss unharmed, only to be stretched apart later, silently shredded in the darkness where no observer can see. This difference raises haunting questions. If no one can witness what happens beyond the horizon, is the destruction of the self even real to the universe? Or does your frozen image on the horizon become your final truth, leaving your true fate unrecorded, unacknowledged? In this paradox lies a tension between appearance and reality, between memory and oblivion. The image of spaghettification captures the imagination because it is so vividly grotesque, yet so eerily precise. It is not chaos, it is the cold mathematics of tidal forces. Every atom of your body obeys the equations of Einstein's relativity, every stretch and tear predicted by the geometry of spacetime. The universe does not rage in violence, it simply unfolds its logic. And within that logic, your humanity is irrelevant. You are reduced to a line of matter, then to dust, then to nothing. And yet, hidden within this annihilation is an echo of eternity. From the outside, your destruction is never truly completed. To distant observers, you never fall in, you linger at the horizon, stretched, frozen, your light redshifted into oblivion. Your death becomes a permanent performance, suspended at the edge of time. In this contradiction lies the strange poetry of spaghettification. You are both destroyed and preserved, annihilated and immortalized. Philosophically, this dual fate confronts us with a question. Is it better to be remembered as an image forever frozen, or to continue onward into the unknown, even if it means being torn apart in silence? The black hole offers no choice. It imposes both fates simultaneously. You are remembered and destroyed, preserved and forgotten. In its grasp, identity fractures into contradictions. The horror of spaghettification also mirrors human fears closer to home. We fear being forgotten, erased, stretched thin by time until our essence is unrecognizable. We fear annihilation, but we also fear eternity, an image of ourselves stuck forever in one moment. The black hole amplifies these fears, turning them into cosmic truths. It is not only a scientific phenomenon, it is a mirror reflecting the deepest anxieties of existence. To think of spaghettification is to realize that the laws of physics do not care about meaning. The universe is indifferent. It stretches and tears because gravity demands it, not because it seeks to punish or preserve. In this silence lies the true terror, not the violence itself, but the absence of intention, the void of care. You do not die in anger or judgment, but in silence, because the cosmos is deaf to suffering. And yet, even here, there is awe. To be spaghettified is to be part of a process that reveals the raw power of the universe. Your body becomes a thread woven into the fabric of spacetime, unraveling into the singularity. It is horrifying, yes, but it is also sublime. To be stretched into nothingness is to brush against infinity, to feel the pull of eternity. In your final moments, you are both victim and witness, consumed yet elevated by the sheer magnitude of what has claimed you. As we leave this chapter of the journey, we carry with us the image of spaghettification, not only as a physical death, but as a metaphor for the human condition. We are all stretched by forces we cannot control: time, memory, history. We are all pulled apart between past and future, self and other, existence and oblivion. The black hole merely reveals, in stark clarity, the fate that shadows us all. From here, the journey leads inward, deeper still. Beyond spaghettification lies the singularity itself, the point where not only bodies, but the very fabric of space and time collapses. If the event horizon is the edge of forever, then the singularity is the end of meaning. And it is into that abyss that we now descend. At the heart of every black hole lies a point so small, so incomprehensibly dense, that language itself fractures when trying to describe it. This is the singularity, a place where the known laws of physics collapse, where time and space lose their meaning, where equations we trust in every other corner of the cosmos are shredded into incoherence. If the event horizon is the veil, then the singularity is what lurks behind it, the end of certainty, the edge of human knowledge, the place where the universe itself seems to whisper, "Here I keep my secrets." From a distance, the singularity is invisible. Its presence is betrayed only by its influence, the warping of space-time, the relentless pull of gravity, the shadow it casts upon the stars behind it. But in theory, the singularity itself is infinite density compressed into zero volume. A star larger than our sun, once alive with nuclear fire, collapses under its own weight after death. The core shrinks smaller and smaller until nothing resists the crushing hand of gravity. All matter, all structure, all distance is compacted into a single point. It is not just the death of a star, it is the death of geometry itself. In everyday life, we trust physics as the script of the universe. Planets orbit in predictable ellipses. Light bends around massive objects according to Einstein's equations. Time ticks forward in steady rhythm, never stalling, never breaking. But in the singularity, that script is torn apart. General relativity, the theory that explains gravity as the bending of spacetime, predicts its own destruction here. Distances shrink to zero, densities rise to infinity, and spacetime curves until it folds in on itself. Relativity tells us the singularity must exist, and yet, at the singularity, relativity ceases to function. It is as if the map guides you faithfully to a cliff's edge and then falls silent, leaving only the abyss. To the human mind, infinity is both a number and a nightmare. We can imagine large numbers, millions, billions, trillions, but infinity is not just larger. It is unending, untouchable, beyond. The singularity embodies infinity in physical form, infinite density, infinite curvature, infinite collapse. It is not simply that matter is compressed, it is that compression has no limit. The universe, so meticulously ordered elsewhere, produces a place where order itself is swallowed. And in that swallowing, meaning collapses too. What does it mean to speak of distance when all distance is zero? What does it mean to speak of time when all timelines converge? The singularity erases not only matter but the concepts through which we describe reality. But if this is the end of physics, it is also the birthplace of imagination. The singularity is not only a grave, it is a canvas for speculation. What happens beyond it? Does space continue into another universe? Is the singularity a bridge, a cosmic tunnel, a gateway disguised as a tomb? Some physicists envision wormholes, portals connecting distant regions of spacetime or even entire other universes. Others argue the singularity is a final boundary, an inescapable full stop at the end of every story. Between these views stretches a spectrum of wonder and fear. To understand why the singularity is such a puzzle, we must look at the tension between two pillars of modern science: Einstein's general relativity and quantum mechanics. Relativity governs the large, the motion of planets, the bending of starlight, the expansion of galaxies. Quantum mechanics governs the small, the flicker of particles, the dance of electrons, the uncertainty built into the fabric of reality. Both theories work with astonishing precision in their domains. Yet, at the singularity, they collide. Relativity insists on a smooth fabric of spacetime that curves without limit. Quantum mechanics insists that nothing can shrink to an absolute point, that uncertainty itself smears reality at the smallest scales. Each theory demands to be heard, and each denies the other's authority. The singularity is the battlefield where these two visions clash, and where, for now, neither emerges victorious. In this sense, the singularity is not only a physical puzzle, it is a philosophical one. It represents the failure of our frameworks, the boundary of human comprehension. Every scientific revolution has been born from such boundaries. The singularity taunts us with the promise of the next revolution, the next leap, the unification of physics. Some future theory, a quantum theory of gravity, a synthesis of the very large and the very small, may finally explain what happens in this abyss. Until then, the singularity is a reminder that even in an age of satellites and supercomputers, mysteries remain. To approach the singularity in thought is to flirt with paradox. Take time, for example. Near a black hole, time slows relative to outside observers. At the event horizon, it appears to stop. At the singularity, time itself ceases to exist, not merely slowed, not merely distorted, but gone. There is no before or after, no sequence of events. In our human lives, time is the current that carries us forward, shaping memory and identity. Without it, what remains of existence? What remains of meaning? Or take space. Normally, we think of space as the stage on which events occur, the backdrop against which matter moves. At the singularity, the stage collapses into itself. Distances vanish. Locations merge. The very notion of where loses sense. To ask what lies inside the singularity is like asking what is north of the North Pole. The question dissolves into absurdity, yet our minds cannot stop asking. And so the singularity confronts us with a choice: accept the limits of knowledge or dare to imagine beyond them. Some thinkers see it as a boundary we will never cross, a permanent veil. Others see it as an invitation, a challenge, a doorway to new truths that our current science cannot yet glimpse. Either way, the singularity functions like a mirror. It reflects not only the universe's mysteries but our hunger to understand, our refusal to be content with ignorance. There is a peculiar irony in the singularity. It is both the smallest and largest concept imaginable. Smallest because it is a point with no size, no dimension. Largest because it contains the totality of everything that has fallen into the black hole, stars, planets, light, matter, energy, all compressed into its depths. It is both nothing and everything, a paradox that defies resolution. In this duality lies its power to haunt us. Cinematically, one might imagine the singularity not as a visible point but as a darkness so complete that vision itself falters, a space where not even imagination can conjure a shape. You do not see the singularity, you sense its inevitability, like the silence before a storm. It is not an object to be observed but an absence that consumes observation itself. In that absence, our most primal fears awaken, the fear of nothingness, the fear of being unmade. And yet, alongside fear, there is awe. For the singularity is not only a threat, it is a clue. It tells us that the universe is stranger than we know, that our theories are provisional, that knowledge itself is unfinished. Every question it raises is a doorway to discovery. To contemplate the singularity is to acknowledge both our smallness and our potential. We are creatures who dare to think about infinities, who dare to map the edges of reality. As we leave this section, the singularity lingers, not as an answer but as a question carved into the cosmos. What happens beyond? Is it destruction or transformation? Is it an ending or the seed of beginnings yet unknown? In the silence of the singularity, physics dies. But in that death, imagination is born. And it is imagination that carries us forward into the next frontier, into the possibility that even where physics collapses, meaning can still emerge. Imagine standing on the rim of eternity, staring into a black hole's abyss. For the traveler falling in, time feels ordinary, flowing as always. Their heartbeat keeps its rhythm, their thoughts continue, their perception unbroken. But for the distant observer, someone watching from far away, something strange happens. The falling traveler never truly crosses the horizon. Instead, they appear to slow down, moving ever more sluggishly, frozen in place just at the edge. Time itself, from the outside, seems to grind to a halt. This paradox is one of the most haunting consequences of relativity. At the event horizon, gravity is so extreme that time dilation becomes infinite. A clock falling into the black hole ticks slower and slower when measured by someone far away, until it appears to stop altogether. It is as though the universe has drawn a boundary not only in space but in time. The horizon is not simply a surface, it is a frozen mirror, reflecting the last visible moment of anything that dares to cross. To visualize this picture, a spaceship plunging toward the event horizon. From the perspective of its crew, the journey is swift and inevitable. They cross the threshold and vanish, swallowed in seconds. But from the perspective of mission control back home, the ship lingers forever at the edge. They watch signals slow, light stretch into red, motion decelerate, until it seems immobile. The crew are forever falling, never fallen. For the outside universe, they are statues cast in the amber of warped time. Light itself is bound by this distortion. The last photons escaping the doomed traveler's ship must climb out of the black hole's gravitational well. As they do, their wavelength stretches, redshifted, until they fade into darkness. The traveler's image grows dimmer, stretched thinner, until it disappears. To the outside, it looks as though the traveler dissolves not by plunging inward, but by being erased from visibility. They are not seen crossing into oblivion, they are seen fading into silence. This creates a profound duality. From one point of view, the fall is swift and unavoidable. From another, it is eternal, suspended forever on the brink. Both are true, depending on where you stand. Relativity has no single answer. It ties truth to perspective. The universe becomes a hall of mirrors, where time is not absolute, but woven differently for each observer. The emotional weight of this paradox is staggering. Imagine you were the traveler. To you, your journey continues. But to everyone who loves you, everyone watching, you never complete it. You are frozen forever at the edge, unreachable, untouchable, slipping away without ever being gone. The black hole becomes not just a cosmic object, but a metaphor for separation. Two perspectives that can never be reconciled, two truths that can never meet. This time-frozen horizon raises unsettling philosophical questions. From the outside, nothing ever falls in. Does the black hole ever truly consume anything? Does the horizon merely collect an infinite gallery of frozen images, each trapped in the final instant of its fall? Or is this just an illusion, a trick of relativity, while the interior reality proceeds unseen? What is more real, the perspective of the one who falls, or the one who remains? The paradox grows deeper when we consider information. If objects appear to halt at the horizon, perhaps their information remains there too, painted onto the surface like a cosmic projection. This idea has inspired theories that black holes might function as holograms, storing the information of everything they swallow on their event horizons. In this sense, the frozen moment is not simply an illusion, but a clue, a hint that reality itself may be encoded at the boundary, not in the depths. And yet, the imagery remains haunting. From far away, every star, every planet, every explorer that dares to cross is etched into an eternal pause. They do not vanish, they are suspended. The horizon becomes a canvas of halted stories, each one ending not with a climax, but with a silence that stretches forever. It is hard not to hear echoes of human experience in this. To lose someone is to feel them frozen in memory, unreachable, yet preserved. A photograph, a last word, a fading image, stilled forever at the edge of recall. In this way, black holes do not only teach us about physics. They remind us of the fragility of perspective, the strange ways in which time holds us, releases us, or erases us. At the event horizon, time is both infinite and fleeting. It is the cruelest paradox. For the falling traveler, an ending comes swiftly. For those who watch, that ending never arrives. Two realities exist, layered atop one another, both true, both incomplete. The black hole, in its silence, refuses to resolve the contradiction. It forces us to accept that time, like truth, may never be singular. As we leave the frozen edge, one mystery lingers. Is the horizon a prison or a portal? Does it mark the end of every story, or the beginning of another chapter hidden from view? The universe offers no answer. Only the haunting image remains, travelers suspended forever at the brink, vanishing into silence, while for them, the journey has only just begun. The paradox begins with something deceptively simple, a thought experiment involving two twins. Imagine them born at the same time, indistinguishable in every way. One remains on Earth, while the other boards a spacecraft traveling near the speed of light. When the traveling twin eventually returns, they discover that much less time has passed for them compared to the sibling who stayed behind. One is younger, one is older, though they were once equal. This is the famous twin paradox, a product of Einstein's theory of relativity. The universe, in its strange indifference, does not allow time to flow equally for everyone. The faster one moves, the slower their clock runs relative to someone at rest. Motion itself bends the river of time. But what happens when we take this paradox and drop it into the abyss of a black hole? Here, time is not only distorted by speed, but also by gravity. The deeper you fall into a gravitational well, the slower time moves relative to those farther away. A black hole, with its unfathomable density, stretches this principle to the extreme. Suddenly, the twin paradox is no longer a simple classroom puzzle. It becomes a window into the way black holes fracture the very fabric of reality. Imagine again our twins, but this time the story unfolds near a black hole. Twin A remains safely in orbit at a great distance, circling in the weak gravity where time ticks almost normally. Twin B, however, dares to venture closer, spiraling down toward the event horizon where gravity is immense. For Twin B, moments pass as they always do, heartbeat steady, thoughts continuous, seconds ticking predictably. But for Twin A, observing from afar, Twin B's clock appears to slow. The closer Twin B drifts to the horizon, the slower they seem to move, until at last their image freezes on the edge, never crossing, never returning. Now, imagine the reunion. Suppose, against all odds, Twin B escapes the pull of the black hole and climbs back to Twin A's orbit. They emerge from the depths of gravity's well only to discover that, while they experienced mere minutes or hours, Twin A has lived through centuries. The twin who dared the abyss returns as a time traveler, stepping into a future that unfolded without them. This is not science fiction. It is the consequence of relativity. Time near a black hole is not just slower, it is radically different. The twin paradox, when played out against this backdrop, is no longer symmetrical or theoretical. It becomes visceral, measurable, irreversible. The emotional impact of this scenario is staggering. Imagine a farewell where you promise to return soon, only to find that everyone you knew has vanished into history. Loved ones are dust, civilizations transformed, languages evolved, all in the span of what felt to you like an afternoon. To fall into the gravity of a black hole is not only to risk destruction, it is to risk dislocation, exile from your own era. This paradox strikes at the very core of human experience. We think of time as shared, collective, something we move through together. Relativity breaks that illusion. It tells us that time is personal, bound to our motion, our gravity, our place in the cosmos. Two people can live the same sequence of events and emerge into utterly different futures. The black hole amplifies this divide to the edge of comprehension. If Twin B drifts near enough to the event horizon, their seconds stretch into eternities compared to Twin A. For the one who stays behind, entire epochs might unfold. Stars may live and die, galaxies evolve, the universe itself grow old, while the traveler remains almost untouched. The twin paradox becomes not a question of years, but of cosmic scales. Philosophically, this raises an unsettling question. What does it mean to share time? If one twin lives in a world where a minute equals a millennium for the other, are they still part of the same reality? Or do they inhabit parallel timelines, separated not by space, but by the very currents of time itself? The black hole reveals that simultaneity, the idea of now, is not universal. It is fractured, fragmented, subjective. There is no single present moment, only countless presents, each bound to perspective. The imagery of this paradox is haunting. Twin A watches Twin B hover at the edge of the abyss, their image frozen, their light stretched into crimson shadows. They wait for a reunion that may never come, knowing that even if Twin B escapes, they will return to a future alien to both of them. Twin B, meanwhile, feels no such pause. To them, time flows naturally. They are unaware of how far the universe has raced ahead without them until they return and see it. Contrast frames the story. For one, an eternal waiting. For the other, an ordinary journey. For one, centuries pass. For the other, minutes. Both are true. Both are real. Relativity does not care about fairness. It only enforces its laws. Some physicists push the thought experiment further. If the twin paradox can stretch across centuries near a black hole, could it stretch across the entire age of the universe? Could a traveler linger at the event horizon, only to emerge into the last flicker of cosmic history, skipping billions of years in what felt like a heartbeat? If so, black holes are not just engines of destruction. They are also one-way time machines, catapulting anyone who dares approach them into the far future. But the paradox does not end there. For what if twin B does not return? What if they cross the horizon, falling into the unseen? From twin A's perspective, their sibling is frozen forever at the edge, never entering, never escaping. From twin B's perspective, they cross swiftly, plunging into the unknown. One twin believes the other is suspended in time. The other believes they have crossed a boundary. Which is true? Both? Neither? Relativity fractures truth itself, binding it to perspective. The emotional resonance of this paradox is perhaps its greatest power. It reveals that time, which we so often trust as solid, is fragile, malleable, unshared. It warns us that the universe is stranger than intuition can bear. It confronts us with the possibility that the person we love most may drift into a reality where our moments never align again. And yet, there is wonder in this tragedy. For the twin paradox is not only a story of loss, it is also a story of survival, of possibility. To linger near a black hole is to step outside of ordinary time, to leap ahead of history, to glimpse a future none of your contemporaries will ever see. It is exile, yes, but also a kind of transcendence. As we leave this thought experiment, the questions remain. Is the twin who ventures near the horizon blessed or cursed? Have they lost everything by skipping across time, or have they gained a glimpse of eternity? And for the one who remained behind, what is worse? To watch a sibling vanish into the abyss, or to wait centuries for their return? The twin paradox, when refracted through the lens of black holes, ceases to be a puzzle of mathematics. It becomes a meditation on separation, memory, and the cruel intimacy between time and gravity. It tells us that the universe does not unfold in unison. It unfolds in fragments, perspectives, paradoxes. It whispers that even the bond of twins, once thought unbreakable, can be stretched across the abyss of eternity itself. For as long as humans have told stories, we have imagined ways to break free from time's relentless current. Legends of eternal youth, clocks that stop, and portals to other eras all reflect our hunger to defy the arrow of time. Yet, for most of history, such dreams remained firmly in the realm of fantasy. Time, after all, appeared unyielding. Seconds became minutes, minutes became hours, hours became years, each following the other like links in an unbreakable chain. Then came Einstein. His theory of relativity shattered the illusion of absolute time and space, revealing instead a fabric called spacetime. In this vast four-dimensional tapestry, time is not fixed but flexible, stretching and bending under the weight of matter and energy. Suddenly, the idea of time travel was no longer purely mythical. It was hidden within the very equations of the universe. One of the strangest predictions of relativity is the existence of closed time-like curves, paths through spacetime that loop back onto themselves. Imagine walking forward along a road, only to discover that every step eventually brings you back to the very moment you began. A closed time-like curve is exactly this, but with time instead of distance. It implies the possibility of returning to your own past, of living in a loop where yesterday and tomorrow collapse into one eternal recurrence. But where could such loops exist? The universe does not create them casually. They demand immense distortions of spacetime, the kind produced only by extraordinary cosmic objects. Black holes, with their extreme gravity, are prime candidates. Theorists have speculated that certain types of rotating black holes, so-called Kerr black holes, may twist spacetime so violently that closed time-like curves arise near their cores. In such a region, stepping forward in time could eventually bring you back to your starting point, as though time itself had curled into a circle. The imagery is both astonishing and unsettling. Imagine a spacecraft skimming the edge of such a loop. To its crew, minutes pass in ordinary rhythm, but as they complete their trajectory, they find themselves in a version of the universe where events have reset. Conversations are repeated, motions replayed, history reenacted. And yet, they remain aware, carrying memories from a timeline that others within the loop seem doomed to repeat. This is where physics collides with paradox. If closed time-like curves exist, then causality, the chain of cause and effect that structures our reality, can be broken. You could meet yourself. You could hand your younger self a message, or worse, prevent your younger self from ever embarking on the journey that brought you there. The infamous grandfather paradox emerges. If you change the past in such a way that prevents your existence, who then made the change? To many physicists, such paradoxes suggest that nature has safeguards against closed time-like curves. Stephen Hawking even proposed the chronology protection conjecture, the idea that the laws of physics themselves conspire to prevent the formation of time loops. According to this view, the universe abhors paradox, and whenever spacetime threatens to bend into a circle, quantum effects intervene to seal the loophole. But not everyone agrees. Some suggest that the universe permits closed time-like curves but enforces a consistency condition. Whatever happens within the loop must be self-consistent. You can travel into the past, but you cannot change it. Every action you take there was already part of history. You may meet your younger self, but only in ways that fulfill the timeline as it already exists. This notion, strange as it sounds, resolves the paradox. If you go back in time, you will not erase yourself. You will only fulfill the events that always happened. The loop does not create freedom, it enforces inevitability. Destiny, not choice, rules the structure of time travel. Still, the philosophical implications are staggering. A universe with closed time-like curves is not linear. It is recursive, cyclical, perhaps even eternal. Events may repeat endlessly, bound in loops that play out across cosmic timescales. If black holes generate such regions, then somewhere in the universe, timelines may already be looping back upon themselves, invisible to us, but endlessly repeating in the shadows of gravity. The emotional resonance of this idea cannot be ignored. Imagine a civilization caught within such a loop, reliving its history again and again without ever escaping. Wars fought, discoveries made, triumphs celebrated, all destined to recur eternally. Would such a people recognize their prison? Would they remember each cycle, or would they remain blind, convinced each repetition was unique? And if awareness came, would it be a curse, knowing that no action could break free from the curve? Contrast helps reveal the weight of the paradox. To most of us, time feels like a one-way journey, fleeting, fragile, irretrievable. Every moment is precious because it passes and cannot return. Closed time-like curves invert this perspective. Instead of scarcity, there is abundance. Instead of irretrievability, there is endless recurrence. The tragedy lies not in time slipping away, but in being unable to escape its repetition. And yet, there is wonder here too. For if closed time-like curves exist, they may be the closest thing the universe offers to immortality. To live within a loop is to never truly end. Each cycle restores you, returns you, revives your narrative. Life becomes a circle without finality, a pattern without conclusion. For some, this may feel like a nightmare. For others, perhaps it is salvation. Physicists wrestle with whether such loops are physically possible or merely mathematical artifacts. Kerr black holes, exotic cosmic strings, and even hypothetical wormholes all provide arenas where closed time-like curves might arise. Wormholes, in particular, offer tantalizing possibilities. If one mouth of a wormhole is accelerated near light speed and then returned, time dilation ensures that the two mouths no longer agree on the same moment. Step through one, and you may emerge in the past relative to the other. This, too, is a kind of gravitational loop, an engineered pathway where cause and effect can bend back upon themselves. But these scenarios remain speculative, fraught with practical impossibilities. Black holes are hostile. Wormholes may be unstable. The energy required to manipulate spacetime at such scales could exceed anything achievable in the universe. And yet, the equations whisper the possibility. Mathematics does not flinch before paradox. It merely sketches the outlines of what might be. The ultimate question becomes not whether closed time-like curves exist, but what they mean for us if they do. Would they allow true time travel with all its paradoxes and possibilities? Or would they simply trap fragments of the cosmos in endless repetition, invisible prisons where time coils upon itself like a serpent devouring its tail? As we contemplate gravitational loops, we encounter a vision of time that is neither linear nor final. Instead, it is recursive, layered, folded upon itself. It forces us to confront the fragility of our assumptions, the strangeness of causality, and the unsettling possibility that our lives may not be as linear as we believe. And so, the mystery remains. Somewhere in the depths of spacetime, perhaps near the heart of a rotating black hole, time may already be looping, replaying, cycling, eternally bound. We may never see it. We may never touch it. The black hole is one of the most terrifying and captivating creations of the universe. At its core lies the singularity, a point of infinite density where the known laws of physics collapse. But wrapped around this abyss is something equally mysterious, the event horizon. The event horizon is not a surface in the ordinary sense. It has no substance, no texture, no atoms or molecules. It is not a wall one could touch or a membrane one could tear. Instead, it is a boundary in spacetime, the ultimate point of no return. For an outside observer, the event horizon appears as a perfect sphere of darkness, an invisible veil that marks the line between the knowable universe and the forbidden depths. Once anything crosses this threshold, light, matter, or even information, it cannot escape. From the perspective of the universe beyond, it is as though the object has vanished forever, erased not just from sight, but from reality itself. And yet appearances deceive. The event horizon may not be what it seems. To the falling astronaut plunging toward the black hole, there is no sudden jolt, no dramatic barrier crossed. From their perspective, space-time remains continuous. They drift across the horizon without resistance, without sensation, unaware that they have entered a realm where return is impossible. The event horizon then is not a thing, but a perspective, a line drawn by observers who remain outside. It exists not as a tangible feature of the universe, but as a construct of perception. This realization shifts the way we understand black holes. The horizon is less like a wall and more like an illusion, a mirage produced by the distortion of time and space. To those who watch from afar, an object falling toward a black hole never appears to cross the event horizon. Instead, its descent slows, its signals stretched and redshifted until they fade into darkness. Time itself seems to freeze at the boundary. From the outside, the astronaut never enters the black hole at all. They become a ghostly silhouette suspended forever at the threshold, fading into invisibility. But from the astronaut's own point of view, the crossing happens smoothly, inevitably. Two truths, both valid, both irreconcilable. The event horizon becomes a theater of paradox, where perception fractures depending on where you stand. Is the astronaut forever at the edge, or are they already gone? The answer depends not on reality itself, but on who is asking the question. Here lies the genius and the terror of relativity. Reality is not singular, but relative. The event horizon demonstrates this with haunting clarity. It is not a fixed, objective line. It is a shifting boundary of perception, an interface between perspectives that cannot be reconciled. For the outsider, The horizon is eternal. For the falling traveler, it is barely a moment. Which version is true? The universe offers no simple answer. This duality gives the event horizon an almost mystical quality. It is at once a barrier and not a barrier, a thing that both exists and does not exist. It is the cosmic illusion par excellence, a stage upon which the laws of physics blur into riddles. Some physicists have gone further, arguing that the event horizon may not exist at all in the form we imagine. Quantum mechanics, with its insistence that information cannot be destroyed, raises profound challenges. If matter disappears into a black hole, does its information vanish too? If so, the fundamental rules of quantum theory are violated. This tension, known as the black hole information paradox, has become one of the most important puzzles in modern physics. To resolve it, some have proposed that the event horizon is not a smooth boundary, but a seething surface of quantum fluctuations, what's been called a firewall. In this view, the falling astronaut would not glide serenely across the horizon. Instead, they would be incinerated instantly upon contact, annihilated by a blaze of energy at the boundary itself. Others reject this radical idea, insisting that quantum information is preserved in subtle patterns woven into the event horizon structure, encoded on its surface like pixels on a cosmic screen. Here we encounter a revelation that reshaped theoretical physics, the holographic principle. According to this idea, everything inside a black hole, the matter, the energy, the information, may not vanish into the singularity at all. Instead, it may be stored on the horizon itself, a two-dimensional surface encoding the three-dimensional contents within. To us, the event horizon looks like a void. But in truth, it may be the ultimate archive, a boundary inscribed with the hidden story of everything that has ever fallen inside. If this is true, then the event horizon is not an illusion of absence, but an illusion of finality. What seems like disappearance is actually transformation. The astronaut who falls into the black hole is not gone. Their information, their history, their quantum identity remains etched into the horizon. It may be scrambled beyond recognition, but it is not destroyed. This reimagining of the event horizon turns terror into wonder. The horizon is not a tomb, but a ledger. It is a surface where reality is recorded, not erased. And yet, it is still an illusion, for no single observer can see both sides of the truth. To the outside universe, the horizon is the end. To the falling traveler, it is a passage. Both are real. Both are incomplete. Contrast sharpens the picture. To us on Earth, horizons are ordinary. They are the line where the sea meets the sky, the edge of mountains, the farthest boundary of vision. We know that they are not walls, but illusions of perspective. No matter how far we walk, the horizon recedes. It is not a place, but a perception. The cosmic event horizon is the same, but amplified to its ultimate expression. It is not the end of space, but the limit of knowledge. Not the destruction of time, but the erasure of certainty. And so, the event horizon becomes a mirror. It reflects our deepest questions about reality. What is the boundary between being and non-being? Between memory and oblivion? Between perception and truth? At the edge of a black hole, these questions are no longer abstract. They are written into the fabric of the cosmos itself. The illusion of the horizon, then, is not a deception, but a revelation. It shows us that reality is not singular, that truth depends on perspective, and that information may survive even in the face of annihilation. The event horizon is not the end of the story, but the beginning of one of the greatest mysteries in science. And beyond that boundary, we are left to wonder, what truly lies within? Does the singularity exist as our equations suggest, or does quantum theory replace it with something stranger, something beyond our imagining? The event horizon keeps the answer hidden, an eternal curtain drawn across the stage of the cosmos. Perhaps, then, the event horizon is not merely a boundary in space. It is a metaphor for knowledge itself. Every horizon marks the edge of what we can see, the border between the known and the unknown. Beyond it lies mystery. Beyond it lies discovery. The cosmic horizon is only the grandest version of a truth that pervades our lives. The closer we approach the edges of understanding, the more we discover how much remains concealed. The event horizon is an illusion, but it is also a promise. A promise that there is always more to uncover, more to question, more to seek. In the vast architecture of the cosmos, where black holes bend the rules of existence and event horizons blur the definition of reality, quantum mechanics introduces its own strange possibility, the chance that nothing is ever truly trapped. At first glance, a black hole seems absolute. Its gravity is so strong that not even light can escape. To us, this means finality. But quantum theory whispers otherwise. It suggests that the universe is not as unforgiving as it seems, that even in the face of cosmic imprisonment, there might be an escape hatch written into the laws of physics themselves. This idea emerges from one of the strangest behaviors in the quantum world: tunneling. In the everyday world, barriers are absolute. A ball thrown at a wall will bounce back, never passing through. But at the quantum scale, particles do not behave so predictably. They exist not as fixed objects, but as waves of probability, spreading into regions that classical physics says should be forbidden. When a barrier rises in their path, a tiny part of the particle's wave function leaks through. Sometimes, impossibly, the particle appears on the other side. It has tunneled through reality itself. Quantum tunneling defies common sense. It suggests that barriers are never absolute, that the impossible always retains a sliver of possibility. The universe, it seems, is not a fortress of certainty but a sea of probabilities, where chance itself holds the keys to escape. Now, imagine applying this principle to the black hole. Classically, the event horizon is unbreakable. But in the quantum world, there is no such thing as an absolute boundary. The fluctuations of spacetime, the jittering foam of quantum fields, mean that the horizon is not a perfect wall but a probabilistic veil. This insight leads to one of the most extraordinary predictions in all of science: Hawking radiation. Stephen Hawking proposed that black holes are not completely black after all. Instead, at their event horizons, quantum pairs of particles constantly emerge from the vacuum. Usually, these pairs annihilate instantly, disappearing back into nothingness. But near a black hole, one particle may fall inside while the other escapes into space. To an outside observer, it looks as though the black hole is emitting radiation, slowly evaporating over unimaginable spans of time. The cosmic prison leaks. The horizon is not an eternal end but a fragile seam where the quantum world asserts itself. This revelation changes everything. If a black hole can radiate, it means information may not be permanently trapped. Quantum tunneling provides the mechanism by which escape becomes possible, even if only as a faint whisper carried on waves of energy. Time, once thought to stop at the event horizon, is given a new dimension. The black hole is not a frozen eternal void, but a process, a cycle, a story that continues. But the mystery deepens. If black holes evaporate through Hawking radiation, what happens to the information of everything that fell inside? Does it dissolve into nothingness, violating quantum law, or does it somehow tunnel its way back out, encoded in the radiation? Physicists debate fiercely, and the answer remains elusive. Some argue that the information is preserved, woven subtly into the radiation itself like a hidden code. Others propose exotic mechanisms, where entire universes may sprout within black holes, carrying their information away into realms we cannot see. In either case, the central theme remains: tunneling challenges the permanence of boundaries. Just as particles can pass through walls, perhaps even time itself can find ways to escape its confines. Imagine standing at the horizon of a black hole, where time appears to stop. To you falling inward, time flows as normal. To the outside universe, you are frozen forever. Two truths, irreconcilable. But quantum tunneling hints that these contradictions may not be final, that there exists a deeper layer of reality where the frozen and the flowing merge, where time is not annihilated but transformed. The implications ripple far beyond black holes. Quantum tunneling is not an abstract trick of physics, but a phenomenon woven into the fabric of existence. It powers the fusion reactions in the hearts of stars, where protons overcome their mutual repulsion not by brute force, but by tunneling through the barrier that keeps them apart. Without tunneling, stars would never ignite. The universe itself would be dark and lifeless. On Earth, tunneling shapes technologies we take for granted. It lies at the heart of semiconductors and electronics, enabling the microchips that define our civilization. In a sense, every time we use a computer or a smartphone, we are harnessing the same ghostly process that allows particles to cheat barriers, the same process that may allow information to escape from black holes. This connection between the everyday and the cosmic is what makes tunneling so astonishing. The same law that lets electrons leap across atomic gaps in our devices may also allow the universe to safeguard its deepest secrets. It blurs the line between the ordinary and the extraordinary, the human and the cosmic, the present and the eternal. And yet, quantum tunneling does not erase mystery. It multiplies it. Barriers are never absolute. What does that mean for the future of the universe? If black holes can evaporate, will the cosmos one day be cleansed of these titans, leaving behind only faint wisps of radiation? Or does tunneling open doors to realms we cannot yet imagine, where time, space, and information flow in ways beyond comprehension? The tension between certainty and possibility defines this story. Classical physics tells us that the black hole is absolute. Quantum mechanics whispers that it is not. Between these two visions lies a contradiction that is not yet resolved. But perhaps that is the lesson. The universe is neither a rigid prison nor a realm of total chaos. It is a place where order and uncertainty coexist, where walls are real but also permeable, where time may stop but also find ways to continue. At the heart of tunneling lies hope. Hope that no prison is eternal, no boundary absolute, no ending final. It tells us that even in the darkest reaches of the cosmos, where time itself appears to halt, the possibility of escape endures. The black hole may be the ultimate symbol of finality, but quantum mechanics reminds us that even there, in the deepest night, the spark of possibility flickers. And so, tunneling becomes more than a technical detail of quantum physics. It becomes a metaphor for existence itself. The barriers we encounter, whether in science, in philosophy, or in our own lives, may not be as final as they seem. There is always a chance, however small, of passing through to the other side. The universe itself is built on this principle. Stars shine because of it. Black holes may dissolve because of it. And perhaps time itself may find ways to escape because of it. The cosmos, then, is not a story of walls, but of doorways. Not a tale of endings, but of transformations. And tunneling in all its improbable wonder is the key. Light has always been humanity's most faithful messenger. It crosses the void between stars, it carries the history of galaxies, and it defines how we perceive the universe itself. Without light, space would be an infinite darkness, silent and unknowable. Yet, in the strange geometries of relativity, light is not only a tool of vision, it is the very thread from which the fabric of time is woven. And when we confront the places in space where time itself appears to collapse, light becomes the final witness, the last signal of a story ending at the edge of possibility. Einstein's theory of relativity tells us that light does not experience time. To photons, there is no before and after, no journey, no duration. A ray of sunlight leaving the surface of a star and striking your eyes has crossed millions of kilometers, yet for the photon itself, that journey is instantaneous. The clock of light does not tick. This fact alone is staggering. Light is the one thing in the universe that rides above the current of time, never dragged forward by its flow. In a sense, light already lives where we imagine time has collapsed. But what happens when light encounters the most extreme environments, where time is twisted beyond recognition? Black holes, collapsing stars, horizons where space-time itself begins to unravel. In these arenas, light's timelessness collides with gravity's hunger, producing visions so paradoxical they appear like riddles carved into the cosmos. Consider a star on the brink of collapse, its core imploding under its own gravity. As the star contracts, its gravitational field deepens, pulling even photons into its grip. To an outside observer, the light escaping from the surface of this dying star becomes stretched, its wavelengths elongated by gravity until it turns redder and redder, a phenomenon called gravitational redshift. At the moment the star crosses the threshold into becoming a black hole, the light ceases entirely. To the universe outside, it is as if the star freezes in time, fading into blackness. And yet, the story from the inside is different. If you were falling with that collapsing light, you would not feel frozen at all. Time would seem normal to you. The collapse would continue, unrelenting. To you, light would still move, illuminating your fall toward the singularity. Two perspectives, irreconcilable, yet both true. This paradox is at the core of how light reveals the collapse of time. To the outside, the story halts. To the inside, it races on. This duality reaches its most haunting form at the event horizon of a black hole. From a distance, a photon emitted just above the horizon will take longer and longer to escape. Its journey outward stretches endlessly. To the observer watching from far away, the photon seems to fade, never quite arriving, trapped on the edge of existence. To the photon itself, of course, the journey is instantaneous. Once again, time collapses differently depending on who you are, where you stand, and how you watch. Light then becomes a kind of boundary marker, a line drawn between the living flow of time and its apparent cessation. It shows us where time fractures into two stories, the perspective of the distant observer and the perspective of the one who falls. And in that fracture, we begin to see why the universe feels so mysterious, why it seems to resist our attempts at absolute truth. But light does more than reveal the collapse of time, it enforces it. Consider the speed of light itself, the ultimate speed limit of the universe. No information, no matter, no signal can travel faster. As you approach this limit, time itself slows. A traveler nearing light speed experiences minutes, while years may pass in the outside world. Push closer still, and the passage of time shrinks toward nothing. To move at the speed of light is to step outside the flow of time altogether. Light, therefore, is not simply a participant in the drama of time, it is the architect of its rules. And what of black holes, those devourers of time? They are defined not by what they contain but by the fate of light at their boundary. A black hole exists because its gravity is so immense that not even light, the fastest traveler in the cosmos, can escape. When light itself falls silent, time collapses behind it. Where photons cannot leave, neither can history. The black hole becomes a tomb of both matter and moments, a place where the arrow of time stops pointing forward. Yet, even in this silence, echoes remain. As Hawking showed, the quantum vacuum at the event horizon produces faint glimmers, Hawking radiation, light born from the uncertainty of the quantum world. These photons carry away not only energy but perhaps the imprint of information, the ghost of what has fallen inside. If true, then light does not simply witness the collapse of time. It rescues fragments of it, smuggling them back into the cosmos in whispers of radiation. Light is, in this sense, the universe's archivist. Every photon that reaches us from a distant star has carried with it a piece of history. We look into telescopes and see galaxies as they were billions of years ago. We gaze at the cosmic microwave background and see the infant universe still glowing from its birth. Light has stored the record of cosmic time, even as it transcends time itself. And at the places where time collapses, it alone remains, marking the boundary between what can still be known and what will forever be hidden. Perhaps that is why humanity has always associated light with knowledge, with truth, with revelation. To walk into the light is to discover. To be cast into darkness is to lose understanding. This symbolism is not mere poetry, it is physics itself. Light is both our vision and the universe's diary, carrying the tale of time's collapse and survival. As we ponder the places where time ends, light is the last companion, the final signal across the void. It is the thread that holds continuity when all else dissolves. And perhaps, just perhaps, it hints that even where time collapses, something endures. For if light itself never ages, then maybe the story of the universe is not bound entirely by time, but by something more enduring, something that shines through even when clocks fall silent. Time is often imagined as an invisible current flowing at the same pace everywhere. We wake, we age, we watch the sun rise and set, and it feels as if the rhythm of existence is unshakable. Yet, relativity dismantled that illusion, showing that time is not universal. It bends, stretches, and even fractures depending on where you stand and how you move. At the heart of this revelation lies one of the most profound phenomena of modern physics: time dilation. Time dilation is not a trick of perception, it is a fundamental reality of the universe. The faster you travel, or the closer you drift toward immense gravity, the slower your clock runs compared to someone far away. To the traveler, everything feels normal. The heart beats, thoughts form, moments unfold. But to the outside observer, the traveler's life ticks away more slowly. Two realities unfold at once, both true, both irreconcilable. Imagine a spaceship leaving Earth and accelerating toward the speed of light. To the crew on board, days pass, conversations unfold, and years seem to stretch ahead as they voyage between the stars. But when they return to Earth, they may find that decades, even centuries, have passed. Friends have aged, civilizations may have shifted, and their own past has slipped into history. The traveler is not a ghost, yet they live out of sync with the world they left behind. This paradox is not science fiction, it is the hard truth of Einstein's equations. This is the essence of the twin paradox, one of relativity's most haunting thought experiments. Picture two twins. One remains on Earth, grounded within its familiar pull of gravity. The other boards a spacecraft, racing outward near the speed of light, then turning back to return. When the traveling twin steps off the ship, they are younger, sometimes dramatically younger, than the sibling who remained behind. Their shared birth no longer anchors them to the same age. Time has fractured their bond, creating two separate rhythms from what was once a single harmony. How can such a thing be possible? The paradox rests in the fact that motion is relative, yet acceleration is not. The twin who traveled was the one who turned, who braked, who shifted velocity. Their frame of reference was disrupted, and the mathematics of relativity dictated that their clock must run slower. In this sense, the universe itself has chosen sides, privileging one twin's journey over the other. But what makes this paradox so deeply unsettling is not just the mathematics, it is the emotional weight. The traveler leaves with the hope of return, believing the passage of time will connect them to home. Instead, they arrive in a world that has outrun them. For the one who stayed behind, life unfolded in a long, unbroken stream. For the traveler, that stream has become a torrent that raced past while they barely noticed. It is as if the universe itself has conspired to separate them. And yet, there is wonder in this too. Time dilation means that interstellar travel, while daunting, is not impossible. For a crew willing to race near light speed, the stars are no longer unreachable. They could cross galaxies within their own lifetimes, even if millennia pass on Earth. To them, the voyage would be achievable, the distances conquerable. Humanity's prison is not the stars themselves. It is the time back home, the gap that widens with every light year crossed. Gravity tells a similar story. Imagine an astronaut hovering close to a black hole, safely outside the event horizon. To them, moments feel ordinary, their heart beats steadily, their voice carries across the radio. But to the observer far away, those signals slow, stretched apart like threads of silk. Seconds become hours, hours become years. The astronaut's time is dilated, bound by the immense gravity. If they return, they will step into a universe older than they ever imagined. This duality raises profound questions about identity, memory, and the nature of time itself. If two people live through the same events at different rates, which one carries the true history? The answer is both, and neither. Relativity denies us the comfort of absolutes. There is no master clock ticking in the heavens, no cosmic rhythm that keeps all lives in step. There are only local clocks, each true to its own frame of reference, each unable to claim supremacy. Perhaps this is the deeper paradox of the traveler. Not that they age differently, but that time itself refuses to be singular. The universe is a mosaic of temporal flows, stitched together by light and gravity. Every star, every planet, every traveler carries their own tempo, and together they form the symphony of existence. Yet, within this symphony, there is melancholy. For the traveler who returns younger than their loved ones, there is joy in survival, but grief in separation. They have gained years of life, yet lost the world they knew. They are both blessed and cursed, holding on to youth while watching history race past them. The paradox is not only physical, but human, forcing us to confront what we value more: the length of our own lives or the shared rhythm of living with others. Science fiction has long drawn on this paradox, weaving tales of explorers who leap forward in time only to find themselves in alien futures. But behind the stories lies the undeniable reality that the universe itself allows this fate. If one day humanity does voyage between the stars, this paradox will not be metaphor, but lived experience. The traveler's paradox reminds us that time is not the gentle river we once imagined, but a restless sea. Motion and gravity sculpt its waves, and each observer sails upon a different current. There is no single truth, only shifting perspectives, each as valid as the other. And perhaps that is the most humbling lesson of all, that time is not ours to command, not even ours to fully understand. It is both gift and thief, both companion and betrayer. For the traveler, it offers journeys beyond imagination, but always at the price of leaving something behind. In the end, time dilation is more than a scientific curiosity. It is a mirror reflecting our deepest fears and hopes about aging, memory, and belonging. It tells us that life is fragile, not just because it ends, but because its rhythm can never be shared perfectly. Every heartbeat, every second, every journey is our own. And in that truth, the universe whispers both wonder and warning. Wherever you go, time will never follow you in the same way again. There is a boundary in the universe where time itself loses its meaning, a horizon not of land or sea, but of existence. Black holes, those invisible giants, mark this boundary with their overwhelming gravity, pulling matter, light, and even time into an abyss from which there is no return. To approach a black hole is to approach eternity. At the heart of a black hole lies the event horizon, the ultimate threshold. From the outside, it appears as a perfect sphere of darkness, a void surrounded by stars. Nothing that crosses it can escape, not even the fastest traveler in the universe, light itself. But beyond its terrifying simplicity hides a paradoxical truth. From the perspective of a distant observer, nothing ever truly falls into a black hole. Instead, objects appear to slow, freezing at the horizon, caught in an endless limbo where time seems to stop. Imagine watching a spacecraft drift toward this edge. The closer it moves, the slower it appears to go. Its signals stretch, its colors shift into deep red, and its motions crawl toward stillness. Eventually, it seems to hang at the horizon forever, an eternal shadow suspended in space. To the observer, the traveler never crosses. Yet, to the traveler themselves, time feels unbroken. They fall freely, crossing the horizon without hesitation, unaware that the rest of the universe sees them frozen in place. Two truths exist at once, separated by perspective, neither one less real than the other. This eternal horizon reveals the most haunting aspect of black holes. They are not simply places in space, but fractures in time itself. The event horizon is not a wall of matter but a wall of experience. On one side, time continues as we know it. On the other, it stretches into shapes that human minds can barely conceive. The closer you move to this edge, the stranger time becomes. Imagine an astronaut hovering just outside the event horizon, engines firing to resist the plunge. For them, moments pass in rhythm with their heartbeat. But for the outside universe, those moments expand into centuries, then millennia. A conversation, a laugh, a single breath becomes stretched into cosmic duration. They live seconds, while stars are born and die in the skies above. This is the cruel paradox of the horizon. To approach it is to separate yourself from the rest of existence. If you were to try and return, you would emerge into a future so distant that Earth itself might be unrecognizable. To the traveler, only hours had passed. To the universe, eons. And what lies beyond, past the horizon? This is the greatest mystery. The event horizon conceals the singularity, a point of unimaginable density where the known laws of physics collapse. Our equations break apart in its presence, unable to describe what happens inside. Some theories imagine that space and time themselves are shredded, collapsing into a state beyond understanding. Others suggest that black holes may conceal gateways to other universes, or that information swallowed by them is somehow stored on their horizons in a cosmic ledger, a memory etched into the edge of eternity. But whether destruction or passage, what is certain is this: once crossed, the horizon is absolute. No return, no warning, no light to signal what lies within. For those who fall, time continues, but their story is forever hidden from the outside. They become part of the black hole's silence, absorbed into a place the universe cannot see. This silence has driven humanity's imagination into overdrive. Entire philosophies emerge from contemplating these eternal horizons. What does it mean for something to vanish from the observable universe? Is existence defined by what can be seen, or can we say that matter swallowed by a black hole still is, in some deeper sense? If time slows infinitely at the horizon, does falling into a black hole mean slipping into eternity, existing forever as a ghostly echo on its surface? Even the idea of eternity here is double-edged. From far away, objects never cross the horizon. They remain frozen forever, suspended in time. In this sense, they achieve a strange kind of immortality, existing endlessly as shadows at the edge. But from their own perspective, they fall swiftly, crossing without hesitation, moving toward a fate unknown. Eternity from one frame is an instant from another. Both are true. Both are unsettling. Black holes force us to confront the limits of our understanding and the limits of our place in time. They are reminders that our reality is not the universe's reality, that our clocks, our histories, our lifetimes are fragile constructs easily broken by gravity. They suggest that eternity is not a realm beyond death but a distortion of time itself, woven into the very fabric of space. To contemplate the edge of a black hole is to confront the possibility that time, the very thing that gives us meaning, can stop existing altogether. And yet, there is beauty here as well. The event horizon, dark and eternal, is not just an abyss. It is also a boundary of knowledge, a place where human curiosity reaches its sharpest edge. Every theory, every equation, every telescope aimed at the sky is a hand stretched toward that boundary, hoping to grasp what lies beyond. Consider the photographs of black holes captured by the Event Horizon Telescope, the glowing rings of light encircling darkness, a cosmic halo marking the point where time itself fractures. For the first time, we have seen the shadow of eternity, and in that shadow lies both terror and wonder. Perhaps the lesson of the eternal horizon is not that time ends, but that our understanding of time is too narrow. What seems like an ending to us may be the beginning of another kind of existence. Just as the horizon of Earth was once thought to be the edge of the world, the event horizon may only appear to be the edge of time. What lies beyond remains hidden, but not necessarily absent. For now, we stand at a distance, gazing into these cosmic abysses, wondering what it means that time itself can be stretched, frozen, and broken. We know only this: to approach a black hole is to approach eternity, a place where moments dissolve into forever. The edge is not a line in space, but a frontier in understanding, a horizon where science, philosophy, and imagination meet. At the eternal horizon, time is no longer a constant. It is a question. And perhaps that question will forever remain unanswered, echoing at the boundaries of what we can see, what we can know, and what we dare to dream. At the edge of a black hole, the universe becomes a stage for illusions. Light bends, time warps, and reality itself fractures into perspectives that defy human intuition. What seems frozen from one vantage point is alive from another. What appears eternal is fleeting. These are not tricks of the mind, but natural consequences of gravity, the most relentless sculptor of the cosmos. Imagine a star wandering too close to a black hole. Its light, once free and radiant, begins to stretch and bend, circling the darkness like a moth caught in invisible currents. From far away, an observer sees the star's glow flicker and fade, its light distorted into strange arcs and crescents. Some of that light will loop around the black hole entirely, returning to the observer's eyes from behind the abyss, creating ghostly echoes of the star in the sky. Multiple images of the same star, warped and repeated, shimmer like mirages in a desert of gravity. This bending of light, gravitational lensing, is one of the black hole's most mesmerizing illusions. It transforms the cosmos into a hall of mirrors, where the boundary between reality and reflection dissolves. Through this lens, we witness stars smeared into arcs, galaxies stretched into glowing ribbons, and the very structure of the universe revealed in ways no straight line could show us. It is as if gravity itself paints with light, reshaping the cosmos into art. But the most unsettling illusion is not one of shape, but of time. To the distant observer, an object approaching a black hole never quite arrives. It slows, darkens, and freezes at the horizon. A spacecraft nearing the abyss would appear trapped in time, locked forever just short of crossing. Its last signals would grow weaker, stretched into longer and longer wavelengths, until they faded into silence. In this view, the traveler never disappears, but becomes an eternal shadow, haunting the edge of eternity. Yet for the traveler themselves, the story is entirely different. They feel no freezing, no slowing. They fall straight through the horizon in a finite span of their own time, watching the outside universe accelerate to impossible speeds. Stars race, galaxies spin, cosmic history unfolds in a blur. To them, It is the outside world that appears distorted, not their own journey. This contrast, frozen from one perspective, flowing from another, is one of the deepest paradoxes of the cosmos. These illusions challenge the very meaning of truth. Which is real, the frozen shadow seen from outside, or the plunging fall experienced within? Physics tells us that both are valid, that reality itself is relative to the vantage point of the observer. In one sense, the traveler is forever suspended at the horizon, etched into cosmic memory. In another, they are swallowed swiftly, carried inward to a fate unseen. The universe holds both stories at once, an unresolved duality written into the fabric of time. Light, too, becomes a player in this drama of illusions. As it struggles to escape the immense gravity of a black hole, its energy drains, shifting into deeper and deeper red tones. This is gravitational redshift, the stretching of light by gravity itself. To an observer, the signals from an object nearing the horizon fade into darkness, not because the object has vanished, but because its light has been stretched beyond detection. It is a slow fading, as though the universe itself is dimming, the flame extinguishing, not in an instant, but across eternity. Even the black hole's appearance is an illusion. The famous image of a glowing ring surrounding darkness is not the black hole itself, but the distorted light of matter swirling around it, heated to unimaginable temperatures as it spirals inward. The darkness is the shadow, the absence where no light can escape. The ring is an optical trick, light bent by gravity into a halo. What we see is not the black hole, but the universe's reflection around it. In this theater of warped light and time, human imagination finds fertile ground. To some, the frozen shadows at the horizon suggest a strange kind of immortality. If nothing truly disappears from our perspective, then perhaps everything that has ever fallen into a black hole is still there, etched onto its surface, suspended at the boundary of time. Entire histories could be trapped as eternal silhouettes, whispers of the past, preserved by the cosmos itself. But the illusion is double-edged. Immortality here is not freedom, but imprisonment. To be frozen at the horizon is to be forever unreachable, visible but untouchable, present yet lost. The black hole grants no return, no communication, no closure. It offers only silence, a silence dressed as permanence. And yet, these illusions also reveal truths. By studying how light bends and stretches, we uncover the structure of spacetime itself. By tracing frozen shadows, we glimpse how gravity reshapes not just matter, but time. Each illusion is a clue, a fragment of reality filtered through the lens of the cosmos. Perhaps the greatest illusion of all is our belief that time is absolute, that reality is the same for everyone. Black holes shatter this belief, showing us that the universe is not a single story, but many, layered and overlapping. From one frame, eternity; from another, an instant; from one angle, silence; from another, collapse. The truth is not singular, but woven from perspectives. At the edges of black holes, we do not simply witness matter consumed, we witness the unraveling of certainty. The illusions remind us that what we see may not be the whole truth, that the universe holds realities beyond our eyes, beyond our instruments, beyond even our imagination. And so, black holes remain both destroyers and teachers. Their illusions are not meant to deceive, but to reveal, to remind us that the cosmos is stranger than we dare to believe. They show us that even shadows can speak, that even silence can teach, and that in the dance of light and gravity, truth and illusion are inseparable. Here, at the boundaries of eternity, the universe becomes a mirror, and in its distorted reflections, we glimpse not only the fate of stars, but the fragility of our own understanding. From the earliest days of human thought, Infinity has haunted the imagination like a horizon that can never be reached. Ancient philosophers stared at the stars and wondered if the universe stretched forever. Mathematicians struggled to define the unending. Poets spoke of eternity, of timeless love, and endless despair. Across cultures and centuries, infinity has been a mirror in which humanity projects its deepest hopes and fears. Infinity is not a number, nor is it a destination. It is an idea that escapes boundaries, a concept that expands beyond comprehension. For the Greeks, it was a peiron, the boundless, the undefined. For medieval thinkers, it was tied to the divine, a quality belonging only to God. For modern science, infinity emerges in equations, in the edges of spacetime, in the singularities of black holes, where mathematics itself breaks. Each era reshapes infinity but never fully contains it. Why does this idea pull at us so strongly? Perhaps because it forces us to confront our own limits. To think of infinity is to realize how finite we are. Our lives, our civilizations, even our planet are but fleeting sparks in an endless dark. Yet infinity also whispers of possibility. If there is no end, then there is always more worlds, more knowledge, more time. Infinity terrifies and inspires in equal measure. Consider the stars. To the naked eye, they form a dome across the night sky, a ceiling of light. Yet we now know this dome is not a boundary but a glimpse into an expanse that stretches beyond imagination. The universe, perhaps infinite, surrounds us on all sides. In that immensity, Earth is smaller than a grain of sand. This revelation does not shrink us, it expands us. To stand under the stars and sense infinity is to feel both fragile and infinite ourselves, for we carry the awareness of it within. Mathematics sharpened humanity's obsession. The invention of numbers brought order to chaos, but infinity always resisted domestication. The paradoxes of Zeno in ancient Greece asked how motion is possible if every distance can be divided forever into smaller and smaller parts. Centuries later, George Cantor revealed that there are not just infinities, but multiple sizes of infinity, some countable, some uncountable, some so vast they stretch even beyond the idea of endlessness itself. Infinity multiplied into infinities, and with it, human wonder deepened. Infinity also crept into human faith. Religious traditions across the world tied the eternal to the divine. Eternal life, eternal damnation, eternal cycles of rebirth, these concepts answered the hunger for permanence in a finite world. Infinity promised a continuation beyond the grave, a story that never ends. It comforted the fearful and humbled the powerful, reminding kings and peasants alike that their lives were but brief episodes in an infinite play. Science, too, found infinity waiting in its equations. The infinite divisibility of matter, once imagined by philosophers, gave way to quantum limits, but infinity reappeared at the boundaries of spacetime. The equations of general relativity predict singularities, points of infinite density and zero volume. Here, infinity is not just abstract but physical, lurking at the hearts of black holes and at the moment of the Big Bang itself. Infinity becomes both a tool and a warning. Wherever it appears, it signals that our understanding has reached its breaking point. Yet infinity is not only found in the cosmos or equations. It lives in human longing. The yearning for eternal love, for unending youth, for limitless knowledge. These are echoes of infinity within us. We are creatures who know our time is finite, and so we dream of the opposite. Infinity becomes both an escape and a curse. Would eternal life be bliss or torment? Would infinite knowledge liberate us, or drown us in meaninglessness? The very thought unsettles us because infinity is not just big, it is boundless, and the human mind is built for boundaries. Stories often explore this tension. In myths, mortals who seek immortality often pay a price, discovering that endless life without change becomes unbearable. In literature, Infinity is a symbol of both the sublime and the horrific, an ocean without shores, a labyrinth without exits. Infinity embodies the unknown, the ungraspable. It is beautiful precisely because it cannot be fully owned. And yet, despite its incomprehensibility, infinity drives human progress. Every scientific quest is, in some sense, a pursuit of the infinite, unending knowledge, endless frontiers. Every artistic creation attempts to capture something eternal, to preserve a moment beyond time. Every spiritual yearning seeks connection with something infinite, something greater than the self. Infinity is the backdrop against which all human striving takes place. This obsession also shapes how we confront mortality. A human life is brief, yet the awareness of infinity gives our briefness meaning. To live knowing the universe stretches endlessly in both directions, past and future, is to realize how precious each finite moment is. Our significance is not diminished by infinity, but framed by it. Just as a single brushstroke gains power within a vast painting, our lives gain weight against the canvas of eternity. Infinity also sparks fear. To some, endlessness is not beauty but terror. An eternal universe without end, an afterlife without escape, or even the infinite void beyond the stars can feel suffocating. Infinity is not always generous. It can be merciless. It strips away boundaries, dissolves finality, and leaves us adrift. For this reason, human cultures often domesticate infinity, giving it shape through stories, religions, or mathematics, ways to make the boundless bearable. Yet the obsession persists because infinity reminds us of possibility. When we gaze into the night sky, we do not just see stars, we see an unending expanse that invites exploration. When we consider eternity, we imagine futures beyond the reach of death. Infinity is not something we will ever conquer, but it is something that will forever guide us, like a compass pointing toward horizons we cannot reach but will always chase. Ultimately, the human obsession with infinity reveals something profound. We are creatures caught between the finite and the infinite. Our bodies are fragile, but our thoughts stretch endlessly. We live brief lives, yet we dream of eternity. We inhabit a tiny planet, but we imagine infinite universes. Infinity is the bridge between what we are and what we seek. Perhaps that is why infinity feels less like an external truth and more like a reflection of ourselves. We are finite beings, haunted and inspired by the infinite, always reaching beyond what we can hold, always yearning for what lies just out of reach. In chasing infinity, we discover not only the cosmos, but our own endless capacity for wonder. What if our universe is not the only one? What if the cosmos we see, the galaxies, the stars, the dark matter and dark energy, are merely a single bubble adrift in an infinite sea of other universes, each with its own laws of physics, its own realities, its own timelines? This is the haunting suggestion of the multiverse, that what we call everything is, in fact, just a fragment of a grander, endless mosaic. At first glance, the idea sounds more like myth than science, a speculation belonging to ancient creation stories or the imaginations of storytellers. But the edge of modern physics has begun whispering the same possibility. The equations of inflation, the strange mathematics of string theory, and the very puzzle of why our universe seems fine-tuned for life all point toward a greater backdrop, a multiverse that may lie beyond our reach, but not beyond our reason. Imagine a cosmic ocean, infinite in scope, where each bubble expands into its own cosmos. Our universe is one such bubble, drifting in this sea. Inside, the laws of physics give rise to stars and planets, to galaxies and black holes, to life itself. But just beyond the fragile boundary of our bubble, another might exist. A universe where time flows differently, where gravity is weaker or stronger, where atoms never form, or where life unfolds in unimaginable forms. The multiverse transforms the mystery of the cosmos into something even grander, not one universe, but countless possibilities stacked against one another like pages in an endless book. One of the strongest hints of the multiverse comes from the early moments of the Big Bang. According to the theory of cosmic inflation, the universe expanded faster than light in its earliest instant, stretching quantum fluctuations into vast structures. But inflation may not have been a singular event. Instead, it may continue eternally in some regions, endlessly spawning new universes in a process known as eternal inflation. In this picture, our universe is not unique. It is one bubble among an infinite froth of bubbles, each born from the same process, yet each carrying its own physical constants. String theory, too, suggests a landscape of universes. By attempting to unite gravity with quantum mechanics, string theory predicts a staggering variety of possible configurations of spacetime, perhaps as many as 10 to the power of 500. Each configuration corresponds to a potential universe with its own laws and constants. The implication is dizzying. What we call reality may be just one point in an unfathomable cosmic library, and the multiverse may contain versions of existence we could never imagine. This concept unsettles because it questions the specialness of our world. For centuries, humans believed Earth was the center of the cosmos. Then came Copernicus, who revealed our planet orbits the sun. Later, we learned our sun is one of billions in the Milky Way, which itself is one of trillions of galaxies. With the multiverse, the demotion continues. Perhaps even our universe is not central, but one among countless others. The more we search for uniqueness, the more the universe whispers that we are adrift in infinity. Yet the multiverse also offers a solution to one of science's greatest puzzles: why our universe seems so finely tuned for life. The values of fundamental constants, gravity, electromagnetism, the strength of nuclear forces, appear perfectly balanced. A slight variation in any would prevent stars from forming, atoms from bonding, or life from existing. Why should our universe be so improbably perfect? The multiverse provides a chilling but elegant answer. In a vast collection of universes, each with different constants, at least one will inevitably allow life. We exist in this universe because it permits us to exist. In this way, the multiverse reframes existence, not as miraculous, but as inevitable. But if the multiverse exists, can we ever prove it? This is where science blurs into philosophy. By definition, other universes would lie beyond our horizon, forever inaccessible. Yet some physicists suggest indirect evidence may already be within our reach. Collisions between bubble universes, if they ever occurred, might leave scars in the cosmic microwave background, the faint afterglow of the Big Bang. Strange anomalies in this radiation have been studied, though none conclusively point to another universe. Still, the possibility lingers. Faint fingerprints of other realities may be written across our sky. There are also echoes of the multiverse in quantum physics. The many-worlds interpretation of quantum mechanics suggests that every quantum decision, every flip of a particle, every split in probability, creates a branching universe. In this picture, reality is not a single path, but a tree with infinite branches. Every choice you make, every roll of dice, every moment of chance, splits into parallel timelines. Somewhere, another version of you is living a different life. Whether this is physical reality or a mathematical interpretation remains hotly debated, but it reveals how deeply infinity creeps into our models of existence. The multiverse idea is both liberating and unsettling. It frees us from the notion that our universe must be the only way things could be, offering an endless array of possibilities. But it also threatens to dissolve meaning. If infinite versions of us exist across countless universes, what makes this version special? If every possibility is realized somewhere, what becomes of choice, of significance, of uniqueness? The multiverse magnifies the mystery rather than solving it. And yet, perhaps that is its greatest gift. To stand at the edge of the multiverse is to stand at the limits of human imagination. It forces us to confront the possibility that reality is larger, stranger, and more layered than we can comprehend. It reminds us that mystery is not an error, but a feature of existence. Just as explorers once stood at the shores of unknown oceans, staring into horizons they could not cross, we now stand at the edge of a multiverse, aware of its possibility but unable to enter. The story of the multiverse is not finished. It may remain forever beyond our grasp, or future discoveries may bring it closer. Perhaps new physics will reveal subtle signs of other universes, or perhaps we will always be left with speculation. But even if we never confirm it, the very idea reshapes us. It stretches the human mind beyond the boundaries of one cosmos, urging us to imagine a reality far grander than what lies in sight. In contemplating the multiverse, we find ourselves at a threshold between science and philosophy, between knowledge and wonder. Whether or not it exists, it reveals something profound about us, that we are creatures who cannot help but ask, what lies beyond? Who refuse to accept the walls of our own bubble as the edge of all reality. And perhaps, in that refusal, we touch infinity itself. Time is often imagined as a river, flowing endlessly forward, carrying us from past to present to future. But what if time is not a river at all? What if it is more like a landscape, where every moment that has ever existed still lies frozen, like towns on a map? In this view, the past has not vanished, the future has not yet arrived, and the present is not the only place where reality resides. Instead, time itself becomes memory, a cosmic archive in which every instant still exists, waiting to be remembered. This idea, known as the block universe or eternalism, is one of the most profound consequences of Einstein's theory of relativity. According to relativity, there is no universal now. For you, this moment is happening here. For someone moving quickly across space, their now is different. There is no single global clock. Instead, spacetime is a four-dimensional fabric, where time is woven into space. The past and the future are simply different regions of this fabric. If so, then the moments we call past are not gone, they are just elsewhere in the structure of spacetime. Imagine a film reel. When we watch a movie, we experience the story frame by frame, one after another, creating the illusion of motion. But the reel itself holds every frame at once, past, present, and future, all existing together. The block universe suggests that reality may work in a similar way. We experience life as a flow, but the universe itself may be a reel with all events eternally fixed in place. We are not moving through time, we are inhabiting our frame within it. This raises haunting questions. If the past still exists, then are those who have died truly gone? Are they still alive in some unchanging region of spacetime, forever inhabiting their moments of laughter, sorrow, or joy? If the future already exists, does that mean it is predetermined, carved into the fabric of the cosmos before we ever live it? In this view, time becomes not a flow, but a landscape, and we are travelers, perceiving one direction of it, blind to the fact that everything is already there. Memory becomes central in this framework. Human memory is fragile, selective, often distorted. We recall moments in flashes, half-formed images, feelings, sense. Yet memory hints at something larger, the possibility that moments can be preserved not just in our minds, but in the structure of the universe itself. When you remember your childhood, are you merely recreating it in your brain, or are you brushing against a region of spacetime that still exists? Perhaps memory is not just a mental reconstruction, but an echo of the eternal presence of the past. But if time is a block, why do we experience it as flowing? Why does the arrow of time feel so undeniable, pushing us from birth to death, never allowing us to reverse course? Physicists answer with entropy, the measure of disorder in a system. The second law of thermodynamics states that entropy always increases. A glass shatters, but shards do not spontaneously form a glass. Heat flows from hot to cold, not the other way around. This increase in disorder creates the arrow of time, giving direction to our experience. In a block universe, entropy explains why we perceive time as moving forward, even if all moments exist equally. This distinction between existence and experience is unsettling. Our minds are wired for narrative, for movement, for change. We remember the past, we anticipate the future, we act in the present. If the block universe is real, these are illusions of perspective, like a flashlight scanning across a frozen painting. We think the painting is being drawn as we move across it, but in truth, it was already finished. Some philosophers argue that this view makes free will impossible. If the future already exists, then every choice we will ever make has already been made. We are simply experiencing it frame by frame, unaware that the ending is already written. Others counter that free will still exists because we are the ones living those choices, even if they are predetermined. Just as a character in a novel does not know the final chapter, we live authentically within our moments, unaware of their place in the larger whole. The block universe also reshapes our understanding of death. If every moment exists eternally, then the moment of your birth is forever real, the moment of your greatest triumph forever present, the moment of your last breath eternally fixed in spacetime. Death does not erase life. It simply means we no longer move into new frames. But the frames we lived remain, like photographs that can never fade. In this sense, to live is to inscribe yourself into the fabric of eternity, to carve moments that will never be erased. Some scientists extend this idea even further. They suggest that consciousness itself may be linked to time, that what we call awareness is simply the act of experiencing a sequence of frames in the block universe. Our minds create the illusion of flow, but reality is timeless. If so, then our deepest sense of being, the feeling of moving through time, may be the most beautiful illusion the cosmos has ever crafted. There is poetry in this vision. Think of a mother holding her newborn child for the first time. That moment still exists. It is not gone, not erased, not swallowed by the abyss of the past. It lives forever in spacetime. Or imagine the last words spoken between lovers, or the silence after a farewell. Those instants, too, remain fixed, shimmering on the map of the universe. Time as memory is not just science. It is a kind of cosmic compassion, preserving everything we are. And yet, this vision carries both comfort and despair. Comfort because it means nothing is truly lost. Despair because it means everything is fixed, even suffering, even tragedy, eternally etched into spacetime. We are left between hope and inevitability, between awe at eternity and fear of determinism. Perhaps this is why the mystery of time has always haunted philosophy and religion. From the Buddhist notion of timeless awareness to Augustine's musings on the nature of past and future, humans have long sensed that time is not what it seems. Science now echoes what mystics have whispered, that time is an enigma, that the present moment may not be the only reality. In the end, when time becomes memory, we are forced to see life differently. Every moment is not just fleeting, it is eternal. Every action is not just passing, it is carved into the cosmos. To live is to create an unerasable record, to weave yourself into the block of existence. Perhaps this is both the greatest weight and the greatest gift, to know that what we do matters, not just now but forever. We have journeyed across black holes, wormholes, quantum paradoxes, and philosophical landscapes. We have followed time to the edges of its collapse and traced its illusions across the universe. Yet, after all the mathematics and metaphors, after all the discoveries and contradictions, one question remains. What does timelessness mean for us, fragile human beings living short lives on a small planet, yearning to understand our place in the cosmos? When we speak of timelessness, it is easy to imagine only abstractions, space-time diagrams, equations, theories. But at its heart, the idea touches something deeply human. For we are creatures bound by time. We grow, we age, we lose. Every tick of the clock is a reminder of impermanence. Children become adults, flowers wither, memories fade. To live is to be pulled along the river of time, powerless to stop its current. And so, the thought that time might not exist, or that it might not work the way we believe, is not just a scientific revelation. It is a crack in the very foundation of what it means to be alive. If time does not flow but simply exists, then our lives are not fleeting candles burning out in the dark. They are constellations, every moment shining forever in the tapestry of spacetime. The laughter of a child, the warmth of a hand held in love, the silence after a farewell, all of these remain unerasable, eternal. This vision brings comfort because it means nothing is ever truly lost. Our lives, though brief in experience, are endless in existence. We are not swept away by time's river, we are woven into its fabric. Yet, timelessness can also be terrifying. If the future already exists, then every choice we will ever make has already been made. The paths we take, the tragedies we endure, the joys we find, all fixed in spacetime. We like to believe we are free, that the future is unwritten, that tomorrow can be different from today. But in the block universe, tomorrow already waits. It is not potential, it is actual. In this view, timelessness robs us of freedom, binding us to a script we cannot change. Between comfort and terror lies a paradox. Timelessness gives us eternity but takes away possibility. And yet, perhaps this paradox is the essence of being human. We live as if time flows, as if our choices matter, as if tomorrow is open. Whether the universe agrees or not, our experience is shaped by that illusion. To act, to hope, to love, all require the belief in change. Even if time is timeless, we are not. We are beings of the present moment, and it is in the present that meaning lives. Consider the ways humans have always sought to defy time. We build monuments to outlast us, write books to speak across centuries, create art to hold feelings beyond the moment they were born. We tell stories not just to entertain, but to preserve, to freeze moments in narrative amber. A song can carry the voice of someone long dead. A painting can capture the gaze of an artist who lived hundreds of years ago. These are human attempts at timelessness, echoes of eternity made with fragile hands. Religion, too, is filled with timelessness. Heaven, nirvana, enlightenment. These are states beyond time, where the soul is not dragged forward by the ticking clock but rests in permanence. Mystics and prophets have spoken of a realm where the past and future dissolve, leaving only a boundless present. Science, in its own way, circles back to the same mystery. When Einstein's equations erase the difference between past and future, when quantum theory suggests all possibilities coexist, when cosmology reveals time itself may have had a beginning, science becomes another language pointing toward the same ineffable truth. Time is not what it seems. So, what does timelessness mean for us? Perhaps it means urgency. If every moment is eternal, then each choice is engraved forever. Every kindness is permanent, every cruelty indelible. We cannot erase what we do, for it will always exist in the fabric of spacetime. To live carelessly is to mark eternity with scars. To live with compassion is to weave beauty into the cosmos itself. Timelessness reminds us that we are not passing shadows but permanent inscriptions. It may also mean presence. If past and future are illusions, then all we truly have is the present. Too often, we are haunted by what has been or consumed by what might come. But timelessness tells us the only reality we experience is now, the breath we take, the light on the horizon, the voice beside us. To live timelessly is not to escape time, but to live more fully within it, to embrace the miracle of being conscious here, now, in this fleeting eternal frame. And finally, timelessness may mean humility. We crave answers, we demand clarity, we long to master the universe. Yet time remains elusive, a mystery at the heart of everything. Perhaps we are not meant to conquer it, but to be awed by it. To look at the stars and realize that we are not outside of time, not above it, but part of it. We are fragments of eternity, living in an illusion of flow, searching for meaning in the silence between ticks of the cosmic clock. As our journey ends, imagine standing at the edge of a vast desert at night. Above you, the stars burn in quiet permanence. Around you, the sands stretch in every direction, endless, unchanging. Time feels like the desert, immense, indifferent, eternal. And yet, in your heart, you feel its pulse, the briefness of your life, the fragility of your moments, the urgency to live. You cannot stop time. You cannot escape it. But you can embrace it, knowing that every breath is carved into the infinite. The human meaning of timelessness is not found in equations or theories alone. It is found in how we live while knowing time is both fragile and eternal, illusory and real. It is found in our choices, our presence, our humility. And perhaps, when we finally accept that time may stop existing in the way we imagine, we can begin to live, not in fear of its passing, but in awe of its mystery. Because maybe, just maybe, we were never moving through time at all. Maybe we have always been timeless.